discussion on demand side management. Okay. So, in fact, I gave an example to make you understand that how much benefit the utility can have if we can follow one of the approaches of demand side management. Okay. Here we will discuss load forecasting. Here we will discuss load forecasting and load management, load forecasting and load management. Okay. Now, as you know, this load, it is having a steady growth, load demand is growing every year and year to year. Okay. And also load grows in a geographical area served by a utility company. Okay. So, load not only grows in magnitude, but also it grows in spatial form. That means, new loads are coming in new areas, small cities, new developed towns and so on. Okay. So, load is a parameter which is continuously growing, okay, for a developing country as well as in developed countries. Okay. And we can find out this load, we need to find out actually as a power system engineer, and that process of finding out this future load demand is called load forecasting. Okay. And it is an important area of research in electrical power system. It is an important area of research in electrical power system. Okay. And not only this power system researchers, they involve in this load forecasting, but it is an area where people of computer science, people of others who know various types of forecasting techniques, they also use means they also do research on this in this particular field. Now, the traditional way to estimate this future load is very simple. We assume some growth percent or percentage growth or per unit growth or whatever you can call. If you know that, then you can find out what would be the load demand after nth year. This P n stands for load demand at nth year. Okay. N is basically that after this n can be any number 5, 10 or whatever, and P naught is basically representing your initial load. P naught is basically representing the initial load, or the load P naught is basically load demand at base year, which we can call 0th year. Okay. And G is basically annual growth rate, okay, and N is the number of years. So, if you know that annual growth rate, which is to be of course constant, okay, then you can find out what would be the load demand after n number of years, provided that you know that load demand at the present year, which is known obviously to us. Okay. Now, this sort of calculation has a drawback, that here we assume that load growth rate is known and it is constant. Load growth rate is known and it is constant, which does not happen in practical world, that load will not grow in a constant percent, that we cannot say that load will always grow at 8% for next 15 years. We can't say that. Okay. So, it may so happen that it will vary from some value 6 to 10 or some value depending upon again that particular country or area which you are talking about. Okay. Now, there are two important notes. Okay. One is called spatial load forecasting, where means in this approach we have where aspect in addition to this how much. So, here not only that how much load demand you are having in the after 10 years or so is important, here also we have some factor that where this sort of load demand happens. That means, load not only grows with the existing customers, load will also grow considering that new customers or new buildings or new residential complex, new offices, new industries will come up. Okay. Suppose this is a geographical area under which a particular utility is serving, and they have a pre existing network like this. So, this is a one feeder and these are the some lateral feeders, and they have many feeders like this. Okay. Now, these are basically existing network by using which that particular utility is serving to certain number of customers, but it may so happen that new residential complexes are developed here. So, new area of load demand. Okay. Now, in order to serve this area, you have to do the expansion of the existing network. Okay. And due to this expansion, for this expansion we need to know how much would be the demand of that new area. Okay. This new area might be an industrial complex, might be an residential complex, might be a shopping complex or commercial complex and so on. Okay. So, in this new area you have to supply power, and that needs the expansion of the existing facilities, and this is the this is why we are basically interested to know where this new load demand comes in. Okay. So, that is why in spatial load forecasting we have where aspect, that not only this load will grow for existing customer, load will also grow in the form that new areas are developed, you have to supply this load. Okay. So, how much factor is basically the spatial factor you can understand. Okay. So, there is another approach which is called small area load forecasting, in which utility basically divide this area into a set of small area and then they forecast this load growth for each of the areas. Okay. Now, this is one way of this load forecasting by trend or regressive analysis. So, based upon this load growth behavior of last few years, we can forecast that how would be the power demand. How can we determine that? We can have this data of this load growth of last, let us say 20 years or so, and then we can fit this data to some characteristics. Okay. And this fitting we can do some by mathematical functions by minimizing this error. We call this analysis as the regression analysis. Okay. And by using so we can find out that the characteristics of load growth. Okay. And this, as we said, this regression analysis main is that if we have this sort of load demand, we assume that a function f x which will relate this load demand with respect to this your time interval, then you can by minimizing this sort of error function. This is not the only this type of this error function that people use, many people use different types of error function, and then we can try to fit these characteristics considering different types of characteristics, linear, polynomial, exponential and so on. Okay. So, main essence is that to find this function f. So, here the main goal is to find out what is how would be the function f which will represent your load growth characteristics. Okay. Now, there is something called small area load forecasting, as I said, where a area is divided into a number of small area, and they use this forecasting for individual area either in substation by substation basis or feeder by feeder basis. Okay. Now, this is the load forecasting, as I said, it is a very big area. So, I do not even discuss a detail on it, I will just touch it to give you some fact that why it is so important in power distribution system planning. Now, there is another important thing which is called load management. Okay. In load management, what we do, it is a process to control some sort of loads indirectly or directly by the individual customers. Okay. So, there is some indirect procedure by which we can manage this load demand, because based upon this load demand the utility needs to schedule the generation and they need to arrange that much of generation available. Okay. So, the process which we can manage this load demand is called load management. Okay. And there are some activities of this load management by which customers are encouraged to suppress their load when at a particular given period of time. For example, during peak demand particularly we need to cut down this load demand, we need to reduce the load demand. If you make some incentives that customer can defer some sort of their load demand during peak hour if they get certain amount of incentives, and these are such activities called demand side management. Again, it is another area of power system research. Okay. I will just give some basic idea on that. Now, what is demand side management? Demand side management is a planning or implementation and evaluation of utility activities designed to encourage customers to modify their electricity consumption pattern with respect to both timing and level of demand. Okay. So, both things are important, that level of demand which is measured in kilowatt or megawatt, and energy which is kilowatt of hour. So, it is a planning process by which utility will encourage customers, okay, to modify their demand based upon some predefined rules or something. They not only try to reduce this level of demand, but also level of energy, okay. And this process is called demand side management. Now, what is the demand side management is important, because as we know, like developing country like India, we have major challenge to meet this increasing energy demand and increasing peak load demand. These are the two important factors. If energy demand is measured in terms of megawatt hour or million of units MU, and peak demand is measured in terms of megawatt in a level of megawatt for a particular country. Okay. Now, if I give a statistics, then probably you will be able to understand this statistics. Again, I sincerely acknowledge for Central of Electricity Authority India for having this data. So, they have their annual reports from which I derived this data in 2017-18. So, here you can find out monthly peak demand and this peak met, okay, and what is the surplus and deficit amount of power that is available, and what is the percentage of this deficit and supply. Okay. Similarly, here as I said, two important factors, one is peak load demand, another is energy consumption in million units. Okay. So, here also we have this energy requirement, the availability and the surplus of deficit, these are all in million units, and percentage of surplus and deficit. Okay. So, this is the monthly report for April, starting from April 17 to March 18, April 17 to March 18. You can find out this, how was the peak load demand of the country. It is in a order of 159,000 megawatt, okay, or 159 gigawatt to sometimes 151 gigawatt, sometimes 158 gigawatt, sometimes in 164 gigawatt, particularly in the month of August, when we have a peak summer in the country. And then this basically column, second column is representing that how much amount of peak demand, this is the peak demand. If you plot this Indian load curve, then this is the demand, this is the maximum demand of all this month throughout a particular month. Now, this second column is representing how much peak was met, and this is basically surplus of deficit. You can see almost all this month we have deficit of of this meeting this peak demand, and that deficit normally typically lies from minus 0.6% to minus 2.9%. So, these are the times when we have this summer in our country. So, and this October is also festive time of this country. So, power demand increases, and so as the deficit of this meeting this peak demand. Similarly, this energy requirement also, if you look at it is higher particularly during this summer time and also this festive time, and then it will get reduced when this winter comes in the country, and these are the availability of this energy, and these are the surplus or deficit energy. Almost every month you can see we have this deficit of energy, and this deficit in terms of a percentage typically lie in between 0.6 to 0.9%, which is according to the percentage not much higher, but we have in a order of minus 614 to minus 905 or 951 million units of shortage of meeting this energy demand. Okay. Now, we have some approaches called demand side management. What are those approaches? These are the some programs which we take for energy saving or conservation program or load management program. So, one is there are two category of demand side management. In one category energy saving or conservation program is taken. This is for example, to replace the less energy efficient equipment by replacing this less energy efficient equipment by less electricity consuming devices. For example, some few years back we had incandescent lamp, which is now replaced everywhere by more energy efficient lamps. Okay. Particularly in lighting sector, there is a huge change. Now, everywhere you will get LEDs which consume very small amount of power. Okay. Now, there are some approach or category of load management through which for reducing this demand or peak period. Okay. All right. So, this we will use for existing resources through demand replacement over time. So, this is basically a process through which these customers are encouraged to reduce the demand peak period. Okay. Now, this demand side management, it includes measures, program, equipment and activities that are directed toward improving the efficiency and cost effectiveness of energy usage for the customer side of the meter. Okay. So, this is a typical definition of this demand side management, by which there are some activities by which we can improve the energy efficiency, we can improve the cost effectiveness, and we can improve also this our load curve. Okay. In general, such load control results in load reduction at time t. Okay. Now, there is an example here. Okay. Now, we have a 5 kilowatt air conditioner which runs 80% of the time. That means, its duty cycle is 80%, it remains on for 80% time. Okay. Now, if we can reduce this duty cycle to 70%, okay, so then what would be the number of minutes of operation it is denied for 1 hour of time? What would be the amount of reduced power consumption? Okay. If we have 100,000 of such air conditioners, and what would be the total amount of peak load reduction? So, we have some air conditioner, it is operated at a duty cycle of 80%, that means 80% of time it will be on, and I want to reduce this duty cycle to 70%. That means, instead of 80% time it will be on, I wish to make it on by 70%. This is a typical type of demand side management. This is a typical type of DSM. Okay. Now, if we can do so, then what would be the number of minutes of operation denied per 1 hour of time, and what would be the reduced power consumption if we have 100,000 of such air conditioner, and what will be the total amount of peak load reduction. So, it is very simple question, but this will give you some facts, some numerical fact through which you can appreciate that even for the reduction of 10% of duty cycle may result in a huge amount of power. Now, if you reduce this duty cycle from 80% to 70%, then per hour you are denying the operation for 6 minutes. That means, additional 6 minutes I am forcing this air condition to be switch off or to be non operational. Okay. And this, since its rating is 5 kilowatt, this will reduce 0.5 kilowatt of 0.5 kilowatt power per hour. Okay. And if we have 100,000 such air conditioner, then if you multiply this with 100,000, then we will get 50,000 kilowatt, that is eventually equal to 50 megawatt of power, which you can reduce. That much of demand is reduced, and that will be eventually very helpful to meet this peak load demand. If you look at these statistics which I discussed few slides back, that we have not only deficit of energy supply, but also we have a deficit of meeting this peak demand. Okay. So, if we can have typically this type of demand side management, we can save megawatts of power. Okay. Similarly, million units of energy as well. Okay. Let us continue and finish it by showing you several possible options for demand side management. Okay. So, before I go to that, I should discuss on the utilities benefits on demand side management. That means, demand side management is nothing but a program for forcing or for by taking some approach, you can create your own load curve, or you can make your own load curve, although the loads are of customer's end. Okay. So, here it is a program by selecting which you are basically diverting this customer's demand in such a way that you can create your desired load curve, okay, which is basically the main goal for this demand side management for an electric utility. Okay. Now, you can see that what are the benefits that electric utility can get. One is, first of all, this maximizing utilization of existing distribution system, which can lead to the deferral of capital expenditures, which is very important. Okay. So, basically if you can shape this load curve according to your desirable shape that you wish to have, then obviously that you will need, you can defer the sum of the important or expensive capital expenditure that you need to meet that load curve. Okay. So, as you have seen that load curve, it basically depends upon how customers are using their load. Okay. Now, there is as such no role for electric utility for shaping that load curve, but if they can take an initiative, that is such kind of an initiative like demand side management, they can somewhat influence to shape to make this load curve according to their desired shape. Okay. And thereby they can reduce their, or they can basically avoid the need of their expensive capital expenditure. I will come to that point. Okay. And they can also shape this, this can be achieved by shaping the daily or monthly or annual load characteristics. Okay. So, as what I was trying to tell you, that it is nothing but to make this load curve according to a desirable shape, or this is nothing but, this program is nothing but to make a load curve which according to your desirable shape and size and characteristics, by forcing this customer, by encouraging these customers with some different approach or some given approaches, okay, which I will discuss. Now, how can we do so? We can suppress certain amount of loads, particularly during peak hour or peak duration hour, or we can encourage this energy consumption during off peak time. As you have seen that two things are concern to us. One is peak demand, that is in power system point of view, that is in megawatt or kilowatt. Megawatt is the level of peak demand for a bigger network, a transmission network. Kilowatt might be a a peak load for a small distribution network. Okay. So, this we need to reduce, this is basically peak megawatt or peak kilowatt. Okay. And also utility should encourage this energy consumption, okay, during off peak hour, and this thereby they can save the units of energy or million units of energy, which is mu. In fact, I have in my last lecture I have shown you that for a utility point of view there are two concerns. One is to meet the total energy demand of the customers, that is in terms of million units, and one is to meet the peak load demand, which is in megawatt, okay, for a bigger network. And these two are the bigger challenges, and that is why so this sort of arrangement, this demand side management is done to reduce or to minimize these two aspects. One is megawatt demand, megawatt peak demand, one is million units of energy. Okay. Now, if they can do so, then they can reduce or they can minimize the requirement of more costly generation, okay, or maybe power purchases from the neighboring grids. Okay. Now, how can they avoid this costly generation? As you know that if your load demand or this peak load demand, it is very sharp peak. Okay. So, during that time there are two options for an utility operator. One is either they can schedule the generation such that it can meet that load demand, or they can go for load curtailment. Okay. The second option is somewhat is not much encouraging options, because load curtailment again gives some sort of less reliability of your system, or it is something that a customer should not welcome. Okay. So, therefore, they have to meet this a sharp peak demand, like this. So, a sharp peak demand. Now, in order to meet this sharp peak demand, so suppose this is power demand with respect to time, and these sharp peak demands may sustain for few minutes, maybe half an hour or 40 minutes, but either you have to reduce that peak or you have to schedule the generation such that it can meet this peak demand. There are two options left for an electrical utility operator. So, therefore, in order to schedule this generation such that it can match this sort of load demand, an electric utility use often the costly generation option, like one of the costly generating option is diesel generator for our country India, because diesel is a costly item, okay, and its generation cost, generation price is much higher, but there is an advantage that it is a quick starter. You can start within few minutes, and accordingly you can utilize it during this peak hour, but it is a costly generation option. But eventually, if you can save this load curve according to your generation available, then you need not to exercise this option like costly generating options. Okay. And also you can relieve the consequence of significant loss of generation. Okay. If you can save this load curve in such that it is less than your available generation, and then even if there is a loss of generation, if a generator trips, that existing generators can match the load demand. Okay. And also it reduce the need of cold pickup. What is cold pickup? Cold pickup is the basically process to start a generator at the very beginning conditions, that means that you do not have the generators in running condition, you are starting it at the very beginning conditions. Now, what are the approaches for this demand side management? Okay. So, here you can see there are many approaches. I will try to discuss this one by one. The one of the approaches is peak saving or peak clipping. That means that suppose this is my load curve, this is my load curve, and this is of course this peak. Okay. So, this is my peak demand, this is my peak demand. So, if you can reduce this peak demand according to this arrow for some extent like this person, then obviously your peak demand will reduce from this value to that value. That means, that is the amount of peak demand you can reduce. So, this is amount of peak demand reduction, amount of peak demand reduction. Then if you can reduce that much of peak demand, then you need only that much of generation, to meet this peak load demand. So, you need that much of generation, which is lesser than this value of course. Okay. Now, this is advantageous for utility. Okay. So, if you can cut down, if you can clip or if you can save this peak demand to some extent, then they need to have that much of generation, and that is of course an advantageous. Okay. Now, based upon this peak saving is again one area for area of power system research. So, peak saving is an area of power system research. Okay. Peak saving or peak clipping, it is an area of power system research, and there are several approaches. If you make a literature review, you will find there is a voluminous literature exists on this particular topic, that is peak saving of power system load. Okay. Now, if you can reduce this amount of load, then you can also defer the need of additional generation, as I was talking about. For example, suppose previously this load demand was 700 kilowatt, okay, and if you can reduce this peak demand to 500 kilowatt or maybe 600 kilowatt, then it means that as if that you avoid the need of 100 kilowatt of generation. So, that means you need to avoid this additional 100 kilowatt of generation. Okay. So, if you do not do so, then either you have to have this additional 100 kilowatt of generation, or you need to curtail this load. So, there are two options only left. Now, in order to meet this 700 kilowatt, this extra 100 kilowatt from where it will come? Either you have to establish a new generation unit or new generators, or you have to purchase in higher cost from the other neighboring grids. So, both options are costlier options, and you can defer this. Now, how can we reduce this sort of peak demand? In fact, this peak demand reduction also lead to significant amount of energy consumption. This energy is, as I have shown you, in the hatch area, in the shaded area. Okay. Now, how can we do that? There are many ways of doing that, and people are proposing different approaches. One of the approaches is efficient control of air conditioner, water heaters. So, these are the two types of loads that we normally use during this peak demand time. For example, in India, when we have very hot summer, we use this air conditioning system to large extent, and this increases our overall load demand, and that is why in this peak load curve you have a significant amount of or significant portion of this your air conditioning load. Okay. So, this peak demand accounts for significant amount of air conditioning load during hot summer in India. Okay. Now, if you can control this air conditioner, I have given an example. If you can have a access that you can control this on and off of the air conditioner, or rather you can control the duty cycle of the air conditioner, then obviously you will be able to cut down this peak. You will be able to reduce the peak. Similarly, you can also control this duty cycle of this water heater as well. So, if you can control this, if you have the control of duty cycle of for operation of air conditioner and this water heater, then you will be come up with reduced amount of peak demand, okay, and that eventually result in your saving of this peak demand. Okay. So, this is one of the approaches. Now, how do you control this? What sort of infrastructure development is required to control such air conditioner? Because air conditioner is at customer end and its operation now still now it depends upon the customer's choice, but utilities do not have any option to control the air conditioner. They cannot simply tell the customers, okay, I have peak demand. So, you need to reduce this, or you need to control your air conditioner. Nobody will listen unless this utility have some access or some control of this customers air conditioning system to regulate their operation. This is not possible. Now, what sort of infrastructure we require, what sort of additional control logic is required, all these things are of research problem and people are working on this. Now, this is another types of demand side management, another approach for demand side management, which is not related to the energy consumption, or neither it related to the energy consumption nor it related to the peak load consumption. Rather, it is related to fill the valley. You look at this load curve, Okay. In this load curve, what you can observe that this is the load curve. So, one thing you can observe that you have a very off peak hour load. So, this is my off peak hour load, off peak hour load demand, and we have a very sharp peak. This is your peak demand, and this peak demand sustains for some small period of time. This time is basically peak load duration hour, and this normally peak load duration hour, as you know, is normally a few minutes, maybe 40 to 45 minutes, or maybe even 1 hour to 2 hours. So, in 24 hours this duration is very small, okay. And thereby if you have such kind of load characteristics, your load factor will be poor, because your average load will be much lesser than this peak demand. So, average demand will be somewhere here. Okay. So, if you know that load factor is a ratio of average demand to the peak demand. So, if average demand is much lower than the peak demand, obviously, this load factor would be poor. That means, most of the time of a day the utility need that much generation only, and only for few minutes they need that much of generation, which is much higher. So, it is basically not economical options for the utility, because they have these generators during most of the time of the day, their generations need to be cut significantly, and only for few minutes they need to be at their peak value or rated value. Okay. So, this is not an economical option, because every generators have some efficiency, and that peak efficiency occurs at certain amount of load demand. Okay. Now, this off peak hour sometimes called valley of this load characteristics, and if you can increase this valley to some value like this, then obviously this will result in this will result in increase of load factor. Okay. So, if you can increase this off peak hour load demand or valley to some extent, then you will be able to increase the load factor. So, this if load factor increases, so this would be beneficial for the utility. Now, the question is how can we do so, because again load, as you know, it is not in the hand of the utility. Okay. So, what we can do, there are various options available. One is that some of the loads are still non electrical loads. Okay. For example, thermal energy. Okay. Thermal energy is not a electrical load. Those countries which need heating, space heating, they can either do it by this electrical by using electrical appliances or by direct transferring and direct heat transfer. So, this thermal energy, if you can convert to the form of electrical energy, then you can fill this valley. Okay. And also there is a huge energy demand in the automobile sector, and this automobile sector till today mostly operates in fossil fuel based IC engines, okay, internal combustion engines, which is not related to any electrical demand, but things will slowly change to this electric vehicle. Now, you might be having this term known to us, at least for us, if you go for any newspaper articles or various newses will come in media, that electric vehicles would be the future to replace the existing IC engine based automobile industries. Okay. So, one of the form of this electric vehicle is battery based. So, battery based electric vehicles, those electric vehicles need some charging. So, they needs battery charging. So, when they need a battery charging, this will come as a new types of load. So, this will come as a new types of load. And the question is, how can you charge this battery, when you will charge this battery, based upon that this load demands of for this battery charging will vary. And if you can encourage this customer for filling this valley during this off peak hour by charging this their battery, then this will be beneficial for the electric utility. Okay. They can increase the load demand during off peak hour, and they can utilize their generation available during off peak hour. Okay. The next one is of course load shifting. Here there will be certain amount of loads which will be shifted from the peak demand to the off peak hour. So, these loads are initially at peak hour. So, this is peak hour and these are off peak hour. So, these are off peak hour. So, these are off peak hour. Okay. Now, if you can shift, you are not basically denying, you are not asking here for this program to not to operate this load, rather you are shifting the timing of this load demand from this peak hour to the off peak hour. Okay. And it will reduce your peak demand, but no change of the total energy. Okay. So, there are two advantages for this type of program. One is peak demand will reduce from this value to that value, whereas this off peak hour demand will increase from that value to that value. Okay. So, this will act as a combination of. So, this program is basically a combination of combination of peak saving and valley filling. So, this is a concept which can do this dual purpose. So, they can reduce this peak demand to that much, they can increase this off peak demand to that much. So, you have both the purpose which will be fulfilled. And how can you do that? So, use of storage device that can that can shift some timing for this energy. So, one of the such kind of thing is electric vehicle charging. Again you can instead of asking to for charging in the peak hour, you can shift it to the off peak hour. How can you make that? You can make some sort of incentive, so that customers will be interested to for this charging in the off peak hour rather than peak hour. Okay. You can make different energy pricing in off peak hour charging and peak hour charging, and thereby you can motivate this customer to use their charger during off peak hour, which will make this dual benefits. Okay. All right. Alternatively, if you have some storage devices, you can store this energy during off peak hour by charging the storage device, and that energy you can utilize during peak hour. Okay. So, charging of storage device can be done in during off peak hour, and this storage device will act as a source of energy during peak demand. So, thereby it will fulfill the both the purposes. Now, there is another form of energy management system, which is called, or demand side management, which is called strategic conservation, strategic conservation. Okay. By doing so, you can reduce the energy consumption. Okay. Reduce the energy consumption. So, this is an way to reduction of energy consumption. Energy, you can write it in terms of megawatt. Okay. So, this is the process of reduction of the energy. Okay. Directly you can ask customer to make some changes, so that overall load curve, which was previously this one. So, this was probably the load curve before you initiate this program. So, load curve before initiating this program. And this is the load curve after initiating this program. So, this is load curve after strategic conservation. Okay. So, this was your previous load curve, and this load curve you are basically saved. You can basically make the shape of the load curve same, but you reduce the load demand at each and every time, not only during peak hour, but also in the off peak hour. So, that this original load curve is shifted to this much, okay, and this will reduce significant amount of energy. Okay. How can you do that? You know that lighting load is something which is changed in fact drastically during last 10-15 years. Okay. So, what was that lighting load 15-20 years back is completely changed, that sort of light do not exist nowadays. Okay. Previously we used incandescent lamp for domestic lighting, okay, and nowadays everywhere you can see LED, okay, which is much energy efficient, okay, if incandescent lamp consumes 100 watt, your one LED they of let us say 15-20 watt can give you similar type of lighting in a similar or better lighting. Okay. So, lighting load is something which you can do for a we can replace by efficient lighting system, and thereby you can have this program strategic conservation. Similarly, air conditioning also air conditioners they are changing. In fact, refrigeration also they are more and more energy efficient nowadays. Okay. So, these are the appliances which will make your strategic conservation successful. Okay. This is a different kind of demand side management program which is called strategic load growth. In that load growth, load as you know it will grow over the years, and accordingly we have to set up all our infrastructure. So, that our infrastructure for electrical utility point of view can meet that load demand. Now, the question is how this load is growing, again that is also not in hand of this utility. Okay. So, this is based upon their customers and the new customers which will come in picture in future, and new sort of appliances also, okay, and their usage, their timing. So, but if you make a strategic load curve, so that strategic load growth, so that your overall this load curve which was previously that much, it is shifted according to what you want. It is shifted to in this upward. So, that the new load curve it's have the same shape, and also the same kind of load factor. Okay. So, what was the load factor here and what was the load factor there, almost same, only thing is that this load is increased. So, if you can make your strategic load growth like this, then you will be able to somewhere a planned way of increasing your infrastructure. So, that this will be capable to meet your future load curve. Okay. And this program you can do by efficient planning operations for power distribution system, including this customers load demand. Okay. And also you can make your network expansion in such a way that load demand will be as per your desirable values. Now, these are the previously whatever I discussed, they are the part of your DSM programs. Okay. And these DSM programs will assist the planner to achieve load reduction or allowing customers to reduce their electricity use. Okay. And one of the aspect by which you can make your demand side management program DSM program successful is by devising a proper pricing energy pricing signal. Okay. Now, as I said this how the customers will use their load and how what sort of appliances when they will use, these are not in the hand of the electric utility, but you can devise a pricing signal. So, that you can motivate this customer indirectly to reduce their consumption during peak, or in order you can encourage the consumption during off peak or by shifting this load. All these programs can be successful with a proper energy pricing signals. And there are many types of energy pricing possible. One is called time of use rate, TOU, okay, which is you can make this energy pricing during peak hour. Peak hour pricing can be 2 to 4 times than the off peak hour. So, this will be the peak hour pricing or peak demand pricing can be much higher than off peak hour. Then automatically the customer will be will be started diverting some of their load from this off peak hour to the peak hour. Okay. Real time pricing is another approach. Okay. So, in this approach, the energy tariff is calculated on the use time, that when you are using. Okay. So, a technique to modify and recalculate the online energy pricing. Okay. So, here the pricing will be time dependent. Okay. So, whenever you are using that particular appliance, accordingly at what time you are using, based upon that your energy pricing will be decided. Similarly, direct load control is another approach. I was talking about if this distribution system operator, if they have direct access to the consumer load, and they can regulate it during peak time. For example, this the operation of air conditioner. So, you can regulate this operation of air conditioner particularly during peak time. So, that you can reduce the load in significant amount, but this needs some pre assigned contact to the customers, and also this needs some changes of the infrastructure, because at the present infrastructure utility does not have any access to the control of any sort of appliance of a customer. Now, also this utilities they need to provide two types of data. Okay. One is the demand data, another is the generation supply data. Okay. And then accordingly this pricing signals can be decided. Another concept is negawatt. Okay. So, you might be observed this thing in some of the textbook. What is that concept? This concept is basically when you have a negative demand, an electrical customers, they might have negative demand. Negative demand means they are basically as if they are providing some generation back to the utility. Okay. And how it is possible? If if a customer has a proper generation infrastructure, and this is possible. How it is possible? That if you have a rooftop solar PV, okay, then a customer can also be a energy producer. So, with the installation of rooftop solar PV, a customer with the installation of rooftop solar PV, a customer becomes a producer as well. Okay. And thereby it can have a capacity to sell the energy to the utility. So, negawatt is basically a negative watt of electricity saved through demand side management is a good as a watt of generation capacity. Okay. For instance, if a utility manages to reduce electricity demand, it can postpone the construction of expensive new power plants or increase reliability. Okay. So, negawatt is basically a concept that you are basically with that any sort of demand side management, you are providing a negative watt. Okay. It means that it is as good as a watt of generation capacity. It is as good as a watt of generation capacity. Okay. Now, how can we do that? We have already discussed all this thing in previous few slides, that how can one customer can be participated in demand side management. Okay. So, this needs new government regulations or directives, and also the utilities need to undertake the DSM program. It is as good as one saving of 1 unit of energy is as good as you are having 1 unit of generation. Okay. Now, we will discuss this energy rate structure or tariff structure. A total revenue that a utility may collect through the scales of service should be equal to the company's total cost of the service. So, this is how this energy rate, this is the thumb rule for devising this energy pricings. So, this is basically thumb rule for devising energy pricing. Okay. So, this is thumb rule for devising energy pricing, and a utility may collect this price based upon that how much cost it requires to provide that particular service, because in fact, this electricity business also a profit making business. So, you as an electrical utility you should devise a pricing strategy, so that it can get the amount of money they are investing back. Okay. Now, there are different types of tariff structure. One is called flat demand rate structure or constant pricing per kilowatt hour. This means that irrespective of your energy consumption, the pricing will be fixed. So, this will be that much of rupees INR per that much of unit of energy. Now, by the way, this unit of energy we make means that 1 kilowatt hour of energy. Okay. Now, based upon this flat demand rate structure, we have a fixed INR or energy pricing in Indian rupees based upon a per unit energy consumption. Similarly, block meter rate structure, in this structure lowest prices would be for greater usage. Okay. So, for industries and bulk customers, this pricing will be lower, so that we can encourage their consumption. Okay. For demand rate structure, separate charges for demand and energy. Basically, in this structure there are two pricings, there are two charges. One is for kilowatt consumption, another for kilowatt hour consumption. Okay. So, based upon your connected load or your demand, your one pricing will be that much of prices per kilowatt, and based upon your net energy consumption, another part would be that much of price per kilowatt hour consumption. Okay. Also, there is one season rate structure. Here higher prices per kilowatt hour used during the season when system peak demand occurs. So, based upon seasonal changes, pricing will be decided, and finally, this time of the day tariff. Okay, structure where these prices per kilowatt hour used during peak period of the day, and this will be higher, that means during peak demand prices will be higher and off peak demand prices will be lower. Okay. So, which I was also talking about in a couple of minutes before. Now, which I was telling in that particular concept, that consumer to prosumer, it means that with having this rooftop photovoltaic cell installed, a customer can sell excess energy to the utility. Okay. So, it means that you are not only saving this energy, but also you are basically producing the energy as well, and this is possible if customer is connected with proper communication link and appropriate incentives. Okay. Then only the customers will be interested to install their rooftop PV on their top of the house, and they can participate in selling this energy. These customers are called prosumers. Prosumers means they are electricity producer as well. Okay. So, for those customers who will consume as well as produce, called prosumer. Okay. So, we come to the end of this part of this lecture, and for this lecture I prepared for these 3 books. One is this H. Lee Will's book, then Turan Gonen's book Electric Power Distribution System, and also Salam and O.P. Malik's book on electric distribution system. So, this I sincerely acknowledge that many of the concepts that which I discussed in this module 1 will are taken from these 3 books. Okay. Thank you finally for attending this module 1.